This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 4, Lesson 3, Power Screws. Lesson 2, size the bearings the shaft spins in. Now we take that rotation and turn it into a straight line push. The job of a power screw in a jack, a press, or a lead screw. We model the screw as an inclined plane wrapped on a cylinder. Build the torque to raise and to lower a load. Then the efficiency and the self-locking test that decides whether the screw holds its load or backs off. Concept 1. The inclined plane model. A power screw is a thread wound helically on a cylinder. Cut one turn free and unroll it, and you have an inclined plane. Its slope is the lead angle, whose tangent is the lead over pi times the mean diameter. The lead is the axial advance per turn, number of starts times pitch, so a single start screw advances one pitch. Raising a load climbs that plane against friction, lowering descends it, and a thrust collar adds a separate friction toll on both directions. Concept 2. The torque to raise and lower. For square threads, the handbook prints both torques, and they share a shape, a thread term plus a collar term. The thread term is FDM over 2 times a fraction built from the lead, the friction, and the mean diameter. Raising adds pi mu dm in the numerator and subtracts mu l below. Lowering flips both. The second term, 1/2 F mu c dc, is the collar friction, the same additive toll in both directions. Keep thread friction and collar friction and the two diameters distinct. These are square thread forms. Acme corrections aren't printed. Concept 3. Efficiency and self-locking. Efficiency is the ideal lift work per turn, F times L, over the actual input, 2 pi times the raising torque, so it uses TR, never TL. Self-locking, ignoring the collar, is pi mu dm greater than the lead, which is just mu greater than tan lambda. Pass it, and the screw holds its load. Lowering takes a positive torque. Fail it, and the load overhauls the screw. TL goes negative, and you need a brake. The printed test is thread only. The collar helps hold, but isn't in it. Setup, the worked problem. A single start square thread jack screw raises 1,000 pounds. We're given the mean thread diameter, the pitch, which equals the lead here because it's single start, the thread and collar friction coefficients, and the mean collar diameter. The plan, lead angle, then the raising torque, the lowering torque, and the efficiency, and finish with the self-locking check. Solve. Part 1. The lead angle, tan lambda, is the lead over pi times d times m, about 0.064, so lambda is under 4 degrees. Then the raising torque, thread term plus collar term, comes to about 183. Notice the drive has to clear this. The shaft torque from Lesson 1, 63,025 HP over N, must exceed TR to lift the load. Solve. Part 2. The lowering torque. Same shape, but the thread fraction flips sign, so the thread term drops to about 43. Add the same collar term, and TL is about 118. It's positive, which means you have to apply torque to lower the load. The screw holds when released. If the thread term had gone negative and beaten the collar term, TL would be negative. The load would backdrive the screw, and you'd need a brake. Solve. Part 3. Efficiency is FL over 2 pi TR, about 17%. Then the self-locking test, mu, 0.15, is greater than tan lambda, 0.064, so the screw self-locks. The low efficiency and the self-lock both tell the same story. A screw that holds its load below 50% efficiency burns most of the input on friction, which is why the lowering torque stayed positive. Traps. 5 ways this bites. 1. Lead versus pitch. The lead is N times the pitch, so a double start screw doubles the lead and shifts everything. 2. The self-lock test is thread only. Don't fold the collar friction into it. 3. Efficiency uses the raising torque, not the lowering one. 4. dm is the mean diameter, halfway between major and minor. The major inflates every torque. 5. Keep thread friction inside the fraction and collar friction in the additive term. Swapping them corrupts both. Quick recall. The lead angle sets the geometry. Tan lambda is the lead over pi dm. The raising and lowering torques share a thread term plus the same collar toll, 1/2 F mu c dc. Efficiency is FL over 2 pi times the raising torque, and the screw self-locks when mu exceeds tan lambda. Golden rule: unwrap to a plane, add the collar toll to both directions, and check mu against tan lambda before you trust the screw to hold. Next up, Lesson 4, Gear Geometry and the Involute. The power screw turned rotation into a straight push. Now we go back to passing rotation between shafts, where teeth mesh. Lesson 4 builds the gear sizing geometry, diametral pitch and module, the pitch circle, and the involute tooth profile that holds the speed ratio steady through the mesh. Everything's at PEPrepEngine.com. Cheat sheet, work solution, and a quiz attached here.
The full study guide, with every equation and common exam trap, is free at PEPrepEngine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.